Recording has started. So, our plan for today looks like this. First, I wanted to go over the homework stuff that you were supposed to do last night. Hopefully, getting these kind of on a short leash this morning. The first couple of periods haven't been exactly intense.
Oh, I thought you guys.
So, plan for today. First thing I wanted to do was I wanted to go over the homework stuff that we were supposed to do last night. Hopefully your C's yesterday are fine to what we've got in that situation there. Okay. Then, if time allows us to, I wanted to get into the next problem set, which deals with similar concepts, but we're going to change the beginning of the situation. That's where we're headed today. Right now, you have a quiz scheduled for tomorrow at the beginning of class. We'll see if we get that far. We'll see how far we get. We might turn it into a take-home. We'll see how that goes. You know, just depends on where we are, what we get done, and what we don't get done. We'll evaluate as we go along. This lab, we might push that back to Monday of next week. We'll see how it goes. Okay. So anyway, that is our plan. Today, we're going to review these acceleration things, and then hopefully start working on the math. All right. So last night, I asked you to work on the back of that first problem set to look at these concepts of acceleration. Okay. So, first, we're looking at answering two questions when we're dealing with these objects. Okay? The problem set is called relationship between velocity and acceleration. But we've also been discussing another thing that's been thrown in there too, right? And we've been looking to answer two questions. I'm going along here. We're looking to answer how fast this object is going at certain points in time, and then how far it's going during those certain points in time. Or it should be in the part that is binder split. Is it like a binder, bunch of bigger binders put together? No, on the red track, underneath today's stuff. Yeah, check it there. So we're looking at, Allison, we're looking at two things, right? How fast the thing's going, how far something is going. Okay? So let's start off with this ramp. Okay? I'll fill in the numbers to begin with and tell me how you did. If you don't see where I got something, then we'll stop. Okay? So first, when we talk about the velocities, because the acceleration is 5 meters per second, this object started at 0, each ball representing 1 second worth of time. That means that here, 5 meters per second, 10 meters per second, 15 meters per second, 20 meters per second, and then finally at the bottom of the ramp would have been going 25 meters per second. Good with those? Any problems with that? Okay. Then, as far as the distances go, how far apart? Okay. This first one, 2.5 meters, 7.5 meters, 12.5 meters, 17.5 meters, and then 22.5 meters. Okay. Any problems with those? Clear? Then, as far as the whole ramp is concerned, a couple of ways we could do it, right? The easiest way would just be add up all these ones that you did here, and doing it that way, you should get 62.5 meters. Okay. The other way that you could do it, if we took away, let's say we took away all of this stuff. Okay. You didn't know any of this. All you knew was that it was 25 meters per second down at the bottom, and then it took 5 seconds to get there. Okay. With just these two numbers, the fact that it started at rest and that it was going 25 meters per second, what would be the average velocity of that object along the ramp? 12.5 meters per second would be the average velocity. Okay? If we've gone 12, now, does that mean we're going 12.5 meters per second along this ramp? Only for a very brief instance. There is one point in time when the velocity is 12.5 meters per second. But most of the time, half of the time, we're going slower than 12.5. Half the time, we're going faster than 12.5. So the average is 12.5.
12.5 is 25 plus 0.
Yep, 12.5. Yeah, 25 plus 0 divided by 2. Then We talked about that. What is the time that it takes to get down that ramp? 5 seconds, right? So if we've gone an average of 12.5 meters per second for 5 seconds, we multiply that together, right? And we would end up with 62.5 meters, just the same way. Okay? Oh, so go ahead. Yes. Basically, yeah. Although I probably have to tell you that. If I didn't give you all the balls, then I'd have to tell you that along the way. But, all right. Are we good here? Okay. So here's what I want to do to transition to the next part. Okay. Let's say I gave you this ring. Okay. Not that ramp. Let's say I gave you this ramp. Okay. But I told you that the acceleration was equal to 10 meters per second squared. Could you do that? What we just did? I really think that most of you could do what we just did. Right? No problem. Do you want to do it real fast?
Yeah. Yeah. Just.
Go for it.
Where you?
But,
Yeah.
no, you don't have to. I mean, you just want to do it in your head. That's fine. Go quick. Chris, why don't you fill the velocities in? Okay.
Velocities?
Yeah, so pick a pen color over on the left-hand side.
I'm guessing.
No, over along the edge of the where you there. Oh, that's fine.
Okay.
That would be 10. That would be 20. That would be 30. That would be 40. That would be 50. And those are all velocities. So Chris, what unit do they have on them?
Meters per second.
Meters per second. Okay. Meters per second. Meters per second. Meters per second. Meters per second. Okay. There's our velocities. Yeah, you can't write your own shit out. Okay, there's that. Okay. Somebody else want to go up and Lexi, you can kind of ask a question. You can answer questions. Ask them what they ask.
I thought right. Let's put them right.
So then, as far as the distances go, right? So pick a different color. Make sure pick a different color on the side. Okay. So during the first interval, how far does it go? 5 meters during the first interval. Okay. Second interval, 15 there. Okay, and then 25 next, right? Yeah. Okay. So that means that the entire ramp, we can do one of two ways, right? We either add them all up, or for the entire ramp, if we go, hold on a second, if we go from here all the way to here, right? Okay. What would be the average velocity? 25 for a total of 5 seconds. That gives us 125. Yes.
Can you just add?
You can either, as far as the distance of the whole ramp goes,
Yeah.
you can either add all the purples together, okay?
Yeah.
Or if we take a look at this big interval that I highlighted in red, right? What would be the average velocity during that time? 25 meters per second.
15.
Okay. There's a couple different ways you can do it, okay? And this kind of came up the other day, but
Oh, I know.
all right. So the one way you can do it is it started at 0, it ended at 50, right? How many velocities is that? How many velocity measurements are there? No. 0 at the beginning, 50 at the end. How many? That's 2 velocity measurements, right? So we can take that and divide it by 2, right? Or we could add up 0 plus 10 plus 20 plus 30 plus 40 plus 50 and divide by 6 if you add the 0 in, okay? Either way, you're going to end up with 25 meters per second. One thing that makes it different, though, is how long does it take to go down the ramp? 5 seconds. So when you do that, you get 125 meters.
How do you know it takes 5 seconds?
Well,
There's
Because there's five, like, right, Sam? If this is 0 seconds, right, each ball is 1 second. Or I just have to tell you that.
Because I was confused because this one, because you got, like, the numbers were the same.
Okay. Here's the go. Yep, add all the purples together. Be one another way to do it. Okay, all right, that's good right there. Yes. Okay. Now, here's what I want you to see. Okay, I'm going to try and do this and make you realize this. Okay, let me get a new sheet. Okay, edit, paste, hopefully the ramp. Okay, good. When we talk about these objects going down the ramp, what's making the ball slide down the ramp? Gravity. Now, which way does gravity act on things? Straight downward. Is this object moving straight downward? It is not. So gravity is making the object go down the ramp. But not the total amount of gravity is making that object go down the ramp. Because gravity's pulling straight down on it, but then that object is moving like sort of diagonally. Does that make sense? So a portion of gravity is making that object move down the ramp. Now, if I tilt the ramp higher and higher and higher, right, how much of gravity is pulling that object down the ramp? More and more and more gravity. And as you get closer and or steeper and steeper, what do we see about the acceleration of that object? It would increase faster, 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 right? If I tilt the ramp so that it is, let me go a little bit more, completely this way, right? If I draw this arrow, okay, now, the ramp is completely vertical, right? How much of gravity is causing that object now to accelerate downward? All of gravity. This ramp and this ramp, the way I have it drawn, and this picture are exactly, this ramp and this picture are exactly the same thing. Exactly the same thing. Okay? What you find out from reading the little portion on the side over there is that gravity causes a constant acceleration or a uniform acceleration. And when you read the problem, hopefully you figured out what is the acceleration that gravity causes. 10 meters per second squared. Technically, it's not exactly 10. It's about 9.8. Right? And that only applies if gravity is the only thing acting on that object, which a lot of times it's not. But at least for starters, let's assume that gravity causes this acceleration of 10 meters per second squared. We said that that was the same as this, right? Here, this is exactly what we just did right here, right? Same exact thing. Okay? So when we go here, if we take a look at the speedometer, if this object starts at 0 meters per second, which it did at the top, right, or the top speedometer, right, after 1 second, how fast is it going? 10 meters per second. After 2 seconds, how fast is it going to be going? It's going to be going 20 meters per second. After 3 seconds, it's going to be going 30.
Wait, after 3.
After 4 seconds, 40. After 5 seconds, 50. And after 6 seconds, 60.
What?
Okay? Now, let's talk about the next part. Okay? The bottom numbers are like the odometer on your car. They tell you how far that object has gone. Does everyone see why the first number is reading as 5? So it went down 5 meters. Yes, that's why I'm reading 5. Right? Do we understand where the 5 came from?
Yeah.
That's so like here, if we go from here to here, right? Okay. what was the velocity at the top of this portion? 0 meters per second. And the velocity at the end of this portion was 10 meters per second. So that means that the average velocity was equal to 5 meters per second. How much time goes by? 1 second. That gives you a total of 5 meters. Okay? Now, here's something that's a little bit different than what we've been doing. Okay? The little odometer on your car, the thing that shows up underneath the speedometer, right? It measures the total distance. Okay? So there's two ways that we can fill out the next one. Right now, I will tell you that the next odometer reading should be 20 meters. I'm telling you that. Okay? The total distance should be 20. So there's two ways we can handle that. Okay? The first way we can handle it, if I take a look at this blue portion, right? What was the velocity at the beginning of this blue line? 10 meters per second, right? At the beginning of that blue line, it was going 10, right? Does that make sense? And then at the end of this blue line, how fast it's going? 20. So that means that the average velocity during that time is how much? 15 meters per second. How much time goes by during this blue portion? 1 second. So that means during the blue portion, how far did it go? 15 meters. But it's already gone how far? 5. So the total is 20. The other way that we could do it would be to go like this. Let's take a look at this green line over here. Okay. How fast was it going at the top of that green line? It was going 0 meters per second at the top of that green line. How fast is it going at the bottom of this green line? 20 meters per second. So the average, I'm going to move this over here. Oh.
Just move it and then draw the line.
So that means that the average during this time frame here was how much? 10 meters per second. But the one thing that's different is how much time has gone by. 2 seconds, right? So we have to multiply that by 2 seconds for a total of what? 20 meters. No, just meters. Does that make sense? Okay. Here's what I want you to do. First of all, did anybody do the odometers or did we get stuck at the odometer?
I just odometer.
Okay.
I did.
So I will tell you, these are the answers. Okay? That's 20. This is 45. Okay? The next one is 80. The next one is 125. The next one is 180. I did some math in my head there. Okay? All right. So, those are the answers to the odometers. Okay, here's what I want to do first, before we do that. Okay. Next to these pictures, there were a couple of questions, right? Yeah. So let's take a look at these questions. See? Let's go back here. We'll go past this. Let's stay here. Not lots of pictures. All right. So for this free fall section, where gravity is the only thing acting on it, the speedometer reading increases by the same amount. How much each second? 10 meters per second. This increase in speed is called the what? The acceleration. More technically, or more specifically, what would we say about the acceleration? It is a what? A constant or a uniform acceleration in this case, because it keeps increasing by 10 meters per second. Next, that was a little harder. Let's save B for a little bit. Okay. C. If it takes 7 seconds for it to hit the ground, the speed at impact is going to be what? 70 meters per second. Okay. The total distance falling. There's a couple ways we can do this. Okay? The answer,
Wait, what was that?
245. Okay?
How do you
So the answer for distance fallen is 245 meters. But the acceleration just before impact is still going to be what though? That's, the acceleration is still 10 meters per second. Okay? Alright, let's take stock. First, do we understand where the 70 came from? Okay. Do we understand where the 10 came from at the bottom? 10 is the acceleration caused by gravity. So just before it hits the ground, it's still gaining speed at a rate of 10 meters per second per second. Alright, let's talk about 245. There's a couple of ways we can do it. Alright? If you go back to this, these odometer readings take us through how long? 6 seconds. So the next thing that we can do, we can say, okay, let's just go the next to 7 seconds, right? How fast was it going at the beginning of this second? It was going 60 meters per second here. How fast is it going down here? 70. That just so happens to be right before it hits the ground. So that means that the average velocity during that time would be what? The average velocity would be 65 meters per second. How much of a time frame are we talking about here? 1 second. So that means that it went 65 meters during that second. But we have to add it to the 180 that it's already fallen. Okay? Same way that we got 15 up here, right? So it's going to be for this purple section, right? If that purple is the next second that goes by, its speed goes from 60 to 70, right? So the average during that time is 65, right? 60 plus 70 divided by 2. Then that's 1 second worth of time, so it goes 65 meters during that time. Okay? But it's already gone 180 meters, so you go 245. Okay. Here, go ahead. This is the average velocity during that time. Because we're during this second interval, 1 second, right? From 6 seconds to 7 seconds. Okay? Do you understand why the velocity was 60 at this point in time? So that means 1 second from now it's going to be 70, because that's what the acceleration of gravity does. Okay? Just like up here, during this second, we went from 10 to 20. The average during that time is 15 meters per second, because we gradually build up between 10 and 20. Here, we gradually build up from 60 to 70. So half the time it's going slower than 65, and half the time it's going faster than 65. Okay, because, so here, let's go this. It's actually on the board, but I'll draw it here so you can read it when you're watching. This is a relationship, it's a velocity relationship, right? And this is how we define velocity, right? We know what the average velocity was, right? How much time goes by during that second? 1 second. If we rearrange this equation, does that make sense? I just multiply both sides by t, right? If I take the velocity that it was going and multiply it by the time that went by, I'll figure out how far it went. Does that make sense? Okay. So that's all I'm doing here with the 65 meters per second times 1 second. I'm just dealing with that second. Okay. Now, with that being the case, we could figure out 245 another way. Okay. If we talk about the whole trip, right, from when it was dropped to when it hit the ground, how fast was it going at the very, very beginning? 0 meters per second. We've already established the fact that how fast was it going right before it hit the ground? 70 meters per second. What was the average velocity during this trip? 35 meters per second is the average velocity. Once again, we've already established here, and this gets into what we were just talking about, right? How long did this trip take? 7 seconds. So we're going to multiply this by 7. Nope, it has to do with how long are we going that fast for, right? If you multiply 35 times 7, any guesses what you'll get? 35. Okay. How's that? Okay, that's fine. If you can do the pattern, that's fine. For now, that's perfectly fine.
Okay, so the acceleration just means like the pattern is just like keeping increasing by the same amount from the previous.
Velocity keeps increasing by
Yeah.
the same amount. Now, just to sort of answer B and sort of make a point to what we finished up with yesterday. At the end of class yesterday, I gave you two equations, right? Do you remember the two equations that I wrote, that I gave for you guys at the end of class today? I'm not saying you have them memorized. I'm just saying, do you remember that I gave them to you?
Oh, the VF equals V.
So, VF equals VI plus A. Ooh, hit the red, or hit the button. Plus A times T. And then delta X equals VIT plus 1/2 AT squared. Okay? Let's talk about the red one first. Okay? The red one we can use to figure out how fast an object is going at a certain amount of time after it starts. Okay? So let's apply this situation. Okay? For this situation, where we just dropped the ball from the top of this cliff, right? What's the initial velocity of that ball? Right when I drop it, it's not doing anything. At the very instant that I drop it, right? So for this problem, to answer go this question down here, right? The initial velocity is 0. What is already established that the acceleration was? 10. How many seconds go by? 7. So that means that the final velocity is equal to 0 plus 10 times 7. What's 10 times 7? 70. If you add that to 0, what do you get? 70 meters per second. Does that make sense? Okay. Mathematically, okay. Now, let's go here. Wait. First, let's finish up the red. Everything we've done so far has been at 1 second intervals. But we can use this equation to find out how fast it's going at any time after we drop it. Let's say I want to find out how fast it's going 2.746 seconds after I drop it. What's the initial velocity of its fall? Still 0, right? What's the acceleration? Still 10, but now for the time, I can plug in any time I want to into that. 2.746 or whatever I decide, whatever it was. That's where this equation, by developing those relationships between velocity and acceleration, we've come up with this is how velocity and acceleration are related to one another. Now we can use that pattern to find out how fast it's going anytime after we drop it. Does that make sense?
Yeah.
Okay? For the next one, for the blue one. Again, delta x means we're trying to figure out how far it's gone, right? What was the initial velocity of that trip? 0. So what happens to this whole term now? If we multiply 0 times any time that goes by, we're still going to get 0. Plus 1/2 times a. What did we establish is already the acceleration? 10. Now, right? Now the time is whatever time we want. But if we take it to this problem down here, specifically what time were they asking for in C? 7 seconds. Okay? You square 7, you get 49. You multiply it by 10, you get 490. You multiply that by 1/2, and you guess what you'll get?
245.
245.
So
Right.
it's find the total distance.
So now, once again, look, yeah, that's the total distance, right? Once again, we established this pattern looking at 1 second intervals. But now that we see the pattern, we come up with the equation and we can figure it out at any time we want to. Good there? Okay. Try to do the front of the sheet that I gave you today. We will definitely talk about it in class tomorrow. Quiz will not be at the beginning of the period tomorrow. We'll see about take home or whether I'm going to save it till Monday. Okay? Good job today, everybody.